Alright, you guys, I'm going to walk you through the 5 different types of problems that we did in this chapter. Alright, our first review problem here is we have a sample of iron being placed into water. We have a final temperature of the mixture, and we're asked to find the specific heat of iron. So you guys, by now, should know that if you have a sample of metal being put into water, that's an indicator that you're going to use the formula M1 C1 delta T1 equals negative M2 C2 delta T2. Remember to keep your metal information and your water information separate so that you don't accidentally mix them up and put them on the same side. So we have an MSc and a delta T for iron and an MSc and a delta T for water. Mass of iron is 225. Specific heat of iron is our unknown. When we're doing the temperature of iron, remember that the temperature of the mixture, the final temperature of the mixture, is the temperature for the final temperature for both. So the temperature change for iron is going to be 41.2 minus its initial temperature, 98.5. So that'll give us a temperature change of iron of a negative 57.3 degrees Celsius. For water, our mass is 72.4. Specific heat of water is 4.18. Temperature change of water, again, you're using that final of the mixture as the final of water and metal. And then we subtract the initial temperature of the mixture, so we get a temperature change of positive 19.2 degrees Celsius. Once you have that information down, you're just going to plug it into the formula. So we're going to have 225 times x times negative 57.3 equals negative 72.4 times 4.18. Kind of ran out of room. We'll just smush it in here. Times 19.2. So on this side, I get a negative 12892.5x equals negative 5810. So x equals a positive 0.451 joules per gram degrees Celsius. So there's your answer. Correct sig figs, of course. Correct unit. Remember, you determine your sig figs simply from the numbers given to you in the problem, not from any calculations you made. So the temperature changes that you calculate don't count for sig figs, just the information from the problem. On to our next review problem here. We're asked to find the delta H reaction for this reaction. That should be an arrow. Obviously just didn't translate. So our reactants are P4 plus 6H2O yielding 4 phosphoric acid. So this is where you would go to your heat of fusion table, which you of course would be provided for the test, and you would just look up the heat of fusion of, heat of formation of these substances. The phosphorus, remember any element has a heat of formation of 0. The water is liquid water, so remember that's the one where you can have two possible choices. You have one value for liquid water, one value for gaseous water, so make sure you're using the liquid one, which is a negative 285.8. And then for phosphoric acid, we have a negative 595.4. So remember the delta H reaction, let's write the formula up here, is the sum, remember that symbol means sum, of the products minus the sum of the reactant. So it's just important to remember to do products minus reactants here. Also remember, if we have a coefficient, I have a 4 in front of the phosphoric acid, I have a 6 in front of the water, you have to multiply your heat of formation by those numbers. So I'll take the heat of formation of phosphoric acid, and multiply it by 4. So 4 times negative 595.4. And then minus the sum of the reactants, so 6 times negative 285.8 plus 0. So on this first one, I get negative 2381.6 minus a negative 1714.8. So that tells me my delta H reaction is negative 666.8. And the unit on this is kilojoules. It's kilojoules because your heats of formation are given in kilojoules. With sig figs here, you don't have to worry too much about them. It should, for the most part, work out. Remember, the rule for addition and subtraction is you go by the number of decimal places. So both the water and the phosphoric acid had 1 decimal place. So my answer has 1 decimal place. It's not total sig figs with addition and subtraction. It's decimal places. Our next one, we have what amount of heat is released when 252 grams of tin is cooling. So remember, if you see that word cool or if you see the word heat, that should be an indicator to you that you're using Q equals MC delta T, which probably at this point is one of the easier equations for you to do. So we'll have Q equals M, the mass, 252, the specific heat, 0.226, and then just remember delta T sign is very important. It's always final temperature minus initial. So that this tin ended at 37.5 degrees. It started at 112 degrees. So that will give me a negative temperature change. So I just type this in my calculator. I get Q equals negative 4242.9. Unit is joules. Of course, we need sig figs. If I look at what's given to me in the problem, I have 3 sig figs, 3 sig figs. Everything has 3. So I will round this. Negative 4240 joules. That last 0 doesn't count because there is no decimal. It does need to be included, though, in order to be a placeholder. You can't round from 4,000 down to 400. You need to put that last 0 in. Make sure when you round to sig figs, you do still include that negative. I saw on the quiz a bunch of you guys would have the negative in the original answer and then forget to include it when you rounded in the sig fig. So the negative is very important. Make sure you include it when you box your final answer. All right, our next one, we have 57 grams of steam condensing to liquid water. So remember, anytime there's a phase changes should shout out to you that you have to do a conversion. I'm giving you the heat of vaporization of water right there, 40.7 kilojoules per mole. So since it's kilojoules per mole, the first thing we have to do is get that grams out of there, right? Water is always 18 grams, 1 mole. So grams cancels. We need to cancel 1 mole on the bottom, 40.7 on the top. And then remember, when you're doing these problems, the last thing you need to do is determine if your heat of fusion or heat of vaporization is negative or positive. We are condensing liquid water, and it even says in the problem the energy is released. So that tells you it's a negative 40.7 kilojoules. So when you solve this, you'll get 128.9. And again, unit is kilojoules because everything but kilojoules has canceled. When we look at our problem to determine sig figs, the 57 grams is going to be what determines it because that has the fewest number of sig figs. It has 2. So we will round this to 2 sig figs, 130 kilojoules. Okay. Oh, negative. Look at me. See, I forgot the negative. Negative 130 kilojoules. Very important, that negative. So don't forget it. All right, last problem is a Hess's law problem. With this one, remember, you will only ever be given an A and a B. You won't be given anything more complicated than this one. What you want to do is look at equation A and find the species in equation A that does not appear in equation B. And actually, for this example, we have lots of choices. We could choose the lead, we could choose the lead oxide, we could choose the lead sulfate. The only thing that does actually appear in both equations is the sulfur trioxide. So let's just pick the lead because it's first. And then we want to do the same thing with B. We want to look at equation B and find something that exists in equation B that does not exist in equation A. And again, we have a couple options. We could pick the water or the sulfuric acid. I'll pick the water just because it comes first, but it doesn't matter which one you pick. As long as you make it exactly match the goal equation, you'll be fine. So let's then, once we've picked what to focus on in A, and what to focus on in B, we will just focus on A and make A, that species that we picked that lead, exactly match the goal equation. When I say exactly match, that means match the number and match the side of the reaction. So the lead here, there's one lead in equation A, there's one lead in our goal reaction, so that tells me I don't have to multiply. The lead is on the reactant side in equation A, it's on the reactant side in the goal equation, so that tells me I don't have to flip it. So I'm actually not going to do anything to A, I'm just going to rewrite it. Pb plus PbO2 plus 2 sulfur trioxide yielding 2 lead sulfates. Since I didn't do anything to the equation, the delta H stays the same, 775 kilojoules. When I look at B, again, I need to make my water exactly match the water in the equation, in the goal equation. So in equation B, I have 1 water. In my goal equation, I have 2 water, so that tells me I have to multiply equation B by 2. We also need to check the placement. In equation B, water is a reactant. In the goal equation, water is a product. So that tells me I also have to flip this equation. So when we flip it, our product, our sulfuric acid, becomes the reactant. And it will become 2 sulfuric acids because I multiplied the equation by 2 as well as flipped it. Yields 2SO3 plus 2H2O. Whatever you do to the reactants and products, you have to do to the delta H. So when I flip the reaction, that changes the sign of my delta H. It was a negative, it will become a positive. I multiplied the reaction by 2, so I multiply my delta H by 2 and I get 226 kilojoules. Now that you have manipulated equation A and equation B, the last thing you want to do is add them together. Remember to cancel out anything that is a reactant in one equation and a product in the other. So in this case, we can cancel out the SO3. That is the only thing we can cancel out, so we're left with lead plus lead oxide plus 2 sulfuric acids, yielding 2 lead sulfate plus 2 water, which exactly matches our goal equation. That tells you that you did the problem right. You didn't make any mistake anywhere. We add the delta H's as well. So my delta H, negative 775 plus 226, gives me a negative 549. And the unit is, of course, kilojoules because the unit of both of our delta H's was kilojoules. Sig fig wise, no decimal points in either delta H, so no decimal points in our answer. And that is the 5 types of problems that we did in this chapter. Hopefully this will help you prepare for your test. You will have to know all of them for your test.